Hello, welcome to SAT Double Take. In this video, we go over two different ways at least to solve a math problem, and the correct way to do it is the one that's best for you. And this is from College Board Exam 1, the No Calculator section, number 13. And in the description, there will be a hyperlink to both versions for this particular question. Okay, so if x is greater than 3, which of the following is equivalent? So I'm going to first solve this the more standard way, certainly the way that the exam expects you to do that, and that's by altering this denominator by making it a common denominator. So we can get right to that. So 1 over x plus 2, I'm just going to write out these denominators. That way it is easier for us to just plug it back in later. And you can also see that this is what we want to do in terms of creating a common denominator by looking at our answer choices. You can see that there is no complex denominator in any of these. Like for C and D, technically they're both 1. Okay, so let's figure out what that's going to be. What that's ultimately telling us that we need to do is multiply both of these denominators by the opposite. Like anytime, x plus 2. Because that's what this denominator is, and then we're going to multiply the original x plus 2 denominator by x plus 3. And whatever you do to the bottom, you do to the top. And that way, we are creating a common denominator without adding any value. Technically, this is 1. This red fraction here is 1. Moving on. So now what we have is x plus 3 over, and if I were to FOIL this out, right, x squared plus 2x plus 3x plus 6. And I know that that's going to be the same for this denominator here. But then this is now a new numerator of x plus 2 over this same exact one here. But I'm actually going to, let me rewrite it here and then I'll go ahead and simplify it after that. Plus 2x plus 3x plus 6. And then this simplifies to x plus 3 over x squared plus 5x plus 6 plus x plus 2 over that same now simplified denominator. And then what I can see is that I can just now add my numerators. That's the whole point of us creating this common denominator, so we can actually combine that numerator. So we have 2x plus 5 over x squared plus 5x plus 6. And I can now see that I'm dealing with this whole fraction here, but it's now over, remember that this is, let me do this in a different color so it's a little bit more obvious. This here, remember, is all taken from us working solely on this denominator. So all that work is now going to go over 1. All of that work we did is now our new denominator, and we see that it's 1 over 2x plus 5 over that. So what is that? That's pretty complicated. Well, not really, if you remember that fractions are just division problems in disguise. So it's 1 divided by 2x plus 5 over x squared plus 5x plus 6. Which is then keep, change, flip when you're multiplying or dividing fractions. So it's now x squared plus 5x plus 6 over 2x plus 5. Let me fix this x because that looks terrible. And bam, 1 times anything is the same. So we actually know that this is our final answer, which is B, a perfect match. So this is a method that if this is what naturally comes to you, that's great because that's the way the exam wants you to go about it. But I also now want to show you kind of a plug and play method that's going to be a common theme when we think about alternative ways of solving SAT math problems. And that is us looking at x is greater than 3. Well, what does that mean x can be? What's the simplest number that x can be that we can plug into this equation and see that if we plugged that same hypothetical number into A, B, C, or D, that we get the same exact answer? Well, what's the simplest number? Well, it would be 4. So what we're going to do here is we're going to say that x is 4. That's totally allowed according to that rule of x being greater than 3. And what we're going to do is we're going to plug it into this equation right here. So 1 over 1 over x plus 2. X is 4, so that's going to be 6. Plus 1 over x plus 3. Well, x equals 4, so we can say that that's 7. And ultimately, we want to start thinking about being a little bit more efficient here because we don't have a calculator. This is the no calculator section. And we can see that this is going to be 1 over 1 plus 1 is 2. But, oh, we don't have common denominators. I understand that. But for the sake of time on the exam, because remember we want to be efficient, we can say that this is about 3.5. And seeing all these numbers here and how drastically different the equations are, I can tell that this is a rounding that's not going to come back and haunt us. And I can now rewrite this as 1 divided by 2 over 3.5. I'm sorry, not denominator 3.5. Denominator 6.5. 6.5. Because 6.5 is halfway between 6 and 7. And we're just kind of averaging those denominators. So then we have 1 times 6.5 over 2, which is roughly about 3.25. So that's what we get when we plug 4 as x into this equation here. And now we want to ask ourselves, which one of these 4 options, when we plug 4 into it for x, is going to give us 3.25? Well, let's start with D and move our way up because I can already see the math here is easier. If x equals 4, I can already tell that this is going to eliminate it as a wrong answer. 4 squared is 16, and you're only adding plus 5x, but this is going to be too big. 2 times 4, that's 8. We're already over what we need. And now we're with A and B. And the beauty of this situation is whichever equation we try, if it's right, it's right. If it's wrong, we know the other one must be right. So let's start with B. And we're going to see that it's 4 squared plus 5 times 4 plus 6. Remember, you always want to plug in the same exact value that you plug into the question into your answer choices whenever you do these plugging style questions. Plus 5. And what we end up with is 16 plus 20 plus 6. Make this a little bit more of a 0. That's 20. Over 8 plus 5. So 8 plus 5 is going to give us 13. And then our numerator, 6 plus 20, that's 26. I'm sorry, 36. 36 plus 6 is going to be 42 over 13. And now what I'm thinking about is how A versus B stacks up. This here, I can see that 13 goes into 42, definitely 3 times with a little bit left over. So we can maybe say like 3.5-ish, right? Like put that little squiggly mark there, something close to that. Well, A is just the inverse of B, which means that ultimately, if I were to work this all out again, this would end up being 13 over 42, which is just it's too small. It's less than 1. And we need a number that's at least 3.25. So it cannot be A, and we can eliminate to B. Once again, the best way to do this is whatever's most natural to you. It's whatever's going to get it done quicker for you on the exam. It's good to know and understand both methods so you can better understand working with these type of like equations and seeing these type of requirements on the SAT. But when it ultimately comes down to it, pick what's best for you on test day. Thank you. Good luck.